Okay, in this video, I'm going to be doing an example of determining whether an alternating series converges or diverges by using the ratio test for absolute convergence. So given this series, first let's identify a sub n as the non-alternating part of this particular series, which would be this. Now what we need to do is we need to determine what a sub n plus 1 is. Now a sub n plus 1 simply means every place we see an n, we are going to add 1 to it. Now be careful. So in this numerator, we have 2n plus 1, but the n is being multiplied by 2. So it's going to be 2 times n plus 1 plus 1. And then in the denominator, it's pretty much the same thing. 2 times n plus 1 plus 1 factorial. So now what we need to do is we need to do the ratio test. Is we want to take the ratio of these. So we're going to say that rho is equal to the limit as n approaches infinity of the absolute value of a sub n plus 1 divided by a sub n. And so what that's going to look like is that is going to look like, first of all, let's take this quantity here and let's simplify it. 2 times n plus 1 plus 1 is 2n plus 2 plus 1, or 2n plus 3. And so that's what we're going to have in the numerator and denominator. I am going to have 7 to the 2n plus 3 divided by 2n plus 3 factorial divided by the original, which was 7 to the 2n plus 1 all over 2n plus 1 factorial. So now comes the simplifying part. So we know we're really going to change this to multiplication by the reciprocal. And so a few other algebraic tricks that we can do here. We're going to break up 7 to the 2n plus 3. So we're going to have the limit as n approaches infinity of the absolute value of 7 to the 2n times 7 to the third all over, and I'm going to put 7 to the 2n times 7 to the 1. So I'm just taking this is going to be in the denominator, right? And I'm moving it over underneath this. Times, we're going to have this now is going to go up into the numerator. 2n plus 1 factorial over 2n plus 3 factorial. All right, so 2n plus 1 factorial and 2n plus 3 factorial. We want to figure out how we can simplify that. But first, we can cancel this out. We can cancel this out. This 7 to the third and 7 to the 1 leaves us with a 7 squared in the numerator. So what we have right now is 7 squared times 2n plus 1 factorial over 2n plus 3 factorial. Now let's see what we can do with that. Well, first of all, 2n plus 2n plus 1 factorial, 2n plus 3 factorial. I'm going to need some more room down here. So 2n plus 3 factorial can be thought of as being 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. So what I've done is I started with 2n plus 3. I subtracted 1 from it to get 2, subtracted 1 from it to get 1. Now let's just show that this does work. Let's say that n was 8. If n is equal to 8, what is 2n plus 3 factorial? Well, 2 times 8 is 16 plus 3 is 19 factorial, which we know is 19 times 18 times 17 is, more room, 19 factorial is 19 times 18 times 17 factorial. Well, let's see if that's the same thing as what's over here. Again, n is equal to 8, so 2 times 8 is 16 plus 3. This is 19. 2 times n is 16 plus 2. This is 18. 2 times n is 16 plus 1 is 17. Factorial. So we see that what we had over here on the left is equal to what we have over here on the right. So this is just a little bit of trick with playing factorials. So what do we have here now? We have 7 squared. This whole thing then reduces to rho is equal to the limit as n approaches infinity of the absolute value of 7 squared or 49, times, what do we have where? So in the numerator, we have 2n plus 1 factorial. We have 2n plus 1 factorial. In the denominator, we have 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. Those cancel. And so we are left with rho is the limit as n approaches infinity. And we can always remove the constant, put it out front. We can even put it out front here. Times the absolute value of 1 over 2n plus 3 times 2n plus 2. Well, we can take the limit now. The limit is clearly going to be 0. And 0 times 49 is 0. So rho is equal to 49 times the limit of this, which is 0, which is 0. And so because rho is equal to 0, it converges absolutely. It has absolute convergence. Absolute convergence. So that's one of those little tricks playing with the factorials that's going to come in very useful. All right, hopefully this was helpful.